A molecular formula is the exact formula of a molecule. It's a multiple of an empirical formula. Sometimes the empirical formula and molecular formula are the same, but not necessarily. If it can be reduced, it's a molecular formula, while if it can't be reduced, then it's an empirical formula. Divide the empirical formula's molar mass by the molar mass of the compound. So what that means is in this problem, it says calculate the molecular formula of a substance, and they give you the empirical formula. And they tell you that this molecular formula has a molar mass of 98.96. Some problems, such as this one, give you the empirical formula. So this is a much easier problem than others. Some problems will give you the information where you have to calculate the empirical and then do what we're about to do. Remember, if you need a refresher on how to calculate empirical, refer back to the last video. So step one is you're going to take that empirical and find its molar mass. It has 1 chlorine, 1 carbon, and 2 hydrogens. So the molar mass of that is 49.476. Then you're always going to take the molar mass they gave you and put it over the empirical's molar mass. That's going to give you some whole number, or something very, very close to a whole number. In this case, that's a 2. That tells me that the molecular formula is twice as heavy as the empirical, so the molecular formula must be twice the empirical. Therefore, I get Cl2C2H4. Notice I just multiply all the subscripts by 2 because that was my multiple. So go ahead and pause the video and try this one on your own. Notice that it asks for the empirical formula and the molecular formula. So first find the empirical and then find the molecular. Restart when you have those two answers. So for the empirical, you had 43.64 grams of P and 56.36 grams of oxygen. You needed to convert both of those to moles. Remember that this isn't a compound, and so our oxygen is not diatomic. Once we get our moles, we compare them. 1.4 is smaller, so we divide both of them by 1.4. But in this case, we did not get whole numbers. We got a 2.5, so we needed to multiply both of them by 2 to get whole numbers. So our empirical formula is P2O5. So now we're going to do what we did a second ago on the first practice problem and find P2O5's molar mass, which comes out to 141.94. They told us the molecular molar mass was 283, so that's going to go on top. And dividing, we get 2. So our molecular formula must be twice as heavy, or P4O10. One more practice problem. Go ahead and pause the video and try this one on your own. Notice that they put the empirical in parentheses and put a subscript for the multiple. So that's another way that you may see it. So on this one, you should have gotten B. So let's see how we got that. So we have our grams of each element. You should have converted them all to moles. Be careful, again, not to put the diatomic masses in there. Then, looking at them, 0.8621 is the smallest, so we divide all of them by that number. And we can see that our empirical should be P1N1Cl2. It has a molar mass of 115.88. So 580 divided by 115.88 gives you 5, which is how we get B as our answer.